the derivative of 3 e to the x is going to be 3 times the derivative of e to the x, and the derivative of e to the x is of course just e to the x. This question is going to require some product rule. I know I didn't write y equals, but I'm just going to do this. I can have a name for the derivative. Y prime will be low d high minus high d low all over low squared, which simplifies a little bit. This is 3x to the 5 plus 3x squared minus 3x to the 5 over low squared. So then that means it's just 3x squared over x cubed plus 1 squared. The derivative of 6 square root of x, I don't know why that green text came with me. Oh, well, let's just ignore that. The derivative of 6 square root of x is going to be 6 times a half is 3. X to the 1 less than a half is negative 1/2. Written another way, that's 3 over x to the 1/2. Number 4 is going to require some quotient rule. The derivative of that, if we call this thing y prime is going to be low d high, derivative of x to the 1/2, remember, is 1/2 x to the negative 1/2, low d high minus high d low, derivative of sine is positive cosine, all over low squared. If I want to write that a little bit better, what I could do is I could multiply the numerator and denominator by, let's do a different color, by 2x to the 1/2. I multiply that to the whole numerator and whole denominator. And on top, the 1/2 and the 2 are going to cancel here, and those are going to cancel there. My first term on the top is just going to be sine x minus 2x to the 1/2 times x to the 1/2 would be x cosine of x over 2 sine squared x root x. Oh, look at that. We got a chunk of orange in that one. Derivative of 5x squared is 10x minus derivative of 2x e to the x. We're going to do product rule, so I'll make sure to subtract the whole thing, right? The product rule of that is going to be something times something plus something times something, but it's going to be minus the whole thing. So let's say maybe I just do the product rule on x e to the x. The 2 I'll just take out of the whole derivative, and I'm just doing derivative of x e to the x. I do f g prime plus f prime g. So that's going to be 10x minus 2 x e to the x plus e to the x. And I don't know, maybe I want to write that another way, or maybe I'm happy as how it is. 6 does not require quotient rule. The derivative of 10x to the negative 2, is this disappearing for you just like it's disappearing for me? Is going to be 10x to the negative 2. I do 10 times negative 2 and get negative 20 x to the negative 3. Well, that was interesting. Which would be negative 20 over x cubed. Maybe it's appearing for you, but for me, this is not appearing right. Let's see. Can I write something here? Okay. Oh, now it's gone. Let's see where it's going. I wonder where it's going. Oh, there it is. There it is. Well, I don't know why it's there, because it doesn't need to be there. Let's try clicking on this page. Maybe that'll help. I did derivative, there we go, of 10x to the negative 2, 10 times negative 2, x to the 1 less than negative 2, and I end up with negative 20 over x cubed. Oh, come on! Microsoft Word, shaking my head at you. derivative of 1/3 cosine is just going to be 1/3 times the derivative of cosine. Derivative of cosine is negative sine. If you mix it up, cosine starts with C, so does the word change. We're going to change the sign when we do derivative of cosine. I don't know. Oh, for a second I was going to say cosine and sine rhyme, but so do sine and sine. So 1/3 times negative sine of x. In other words, I end up with negative sine of x over 3. The derivative of, let's get rid of this stuff because it's in the way. I'm never going to be able to post this for you to just look. I'm just going to have to post the video. Derivative of cosine is negative sine. And the derivative of negative 1/5 x is going to be negative 1/5. Here's a tricky one. Derivative of 10e squared. That's a constant. This is all times x to 0. The derivative of a constant is 0. Derivative of 1/2 sine will be 1/2 cosine. Derivative of e to the x minus 10x will be derivative of e to the x is e to the x. Derivative of negative 10x is negative 10. This next question, number 12, does not require a quotient rule. It requires you to recognize that we are doing derivative of x to the negative 5/2, which means it'll be negative 5/2 x to the 1 smaller. Negative 5/2 minus 1 makes negative 7/2. If you want to write that like negative 5 over 2 x to the 7/2, you can do that. You don't have to. Simplified is an opinion, and everyone's entitled to their own opinion. Number 13. Ooh, here it's getting interesting. If I call this y prime is going to be, I'm going to do product rule. So, product rule says I do f g prime, so in a second I'll fill in g prime, plus f prime g. What I'm doing here is I'm procrastinating, right? I'm filling in the parts that I can do really quickly. And I left enough space so that I could do the g prime. Derivative of sine x minus cos x is going to be derivative of sine x minus derivative of cos x. So minus negative sine plus sine, which means I have an e to the x cos x plus e to the x sine x plus e to the x sine x minus e to the x cos x. Oh, look at that, we got some cancelling. Some e to the x cos x and e to the x cos x cancels out. And I end up with 2 e to the x sine x. Number 14 is a polynomial. Oh, bless number 14, because I could do derivatives of polynomials all day long. 3 times 4 is 12. 1 less than 3 is 2. Derivative of 11x is going to be 11. Derivative of a constant is 0. I don't really need to write plus 0. Number 15, if you do... Am I able to scroll now? Oh, come on, there we go. Number 15, if you do quotient rule, you're not wrong, but you're also kind of wasting your time. We're doing derivative of x squared minus 1 over x to the 1/3. That means I'm doing derivative of, I could distribute the denominator to both things. I could do x squared over x to the 1/3 minus 1 over x to the 1/3. That comes out to derivative of x to the 2 minus a third. 2 minus a third means I'm doing 1 2/3, so 5/3. I guess, man, I don't know if I feel like I did that the long way. I really should have done 6/3 minus 1/3 makes 5/3. Minus 1 over x to the 1/3 means it's minus x to the negative 1/3. Now that it's in this x to the n power form, I could do some power rule. Bring down the power, make it 1 smaller. Bring down the power, negative 1 times negative 1/3 means I'm doing plus 1/3. Make the power 1 smaller. And then I could factor and make it more simplified, but that's fine just as it is. Number 16. Oh, remember that time I said plus 14? Plus 16. What a nice problem. Derivative of a constant is 0. Number 17, it's going to be product rule. Look, I've done this exact one before. F G prime plus F prime G. Look at that, it's coming along for a ride. Get out of here. Oh, there you go. Oh, listen to me. I feel so powerful. Derivative of this, I will do some quotient rule. Low D high minus high D low over low squared. And I could, okay, I'll cancel out an e to the x. It's just screaming at me, hey, I could divide everything on top by e to the x and everything on bottom by e to the x. I get this, which that kind of looks, it's simplified enough. Let's not get crazy here. That does kind of look like negative x squared plus 2x minus 1 is going to be negative x minus 1 squared. That's neat. Okay. Number 19. Do I need to erase it? Come on, get out of here, purple. Nope, I'll have to erase it. Number 19, I don't have to do quotient rule. I do have to erase. Not that I need that much space, because number 19 simplifies before I ever do derivative. I'm just going to simplify this to 3x squared over x minus 11x over x plus 2 over x, which is 3x minus 11 plus 2x to the negative 1. I haven't even done a derivative yet, right? This is still y equals. Y equals. When I do my derivative, y prime equals, it'll be easy for me to do it now because now it's not a quotient. Now it's just a polynomial-ish. The 2x to the negative 1 isn't polynomial, but it's all power rule. Derivative of 3x is 3. Derivative of negative 11 is 0. Derivative of 2x to the negative 1 is negative 2x to the negative 2. So I have 3 minus 2 over x squared. Oh, derivative was even simpler than the original. Actually, it wasn't, because the original wasn't that bad either. Number 20, it's a good one. Let's just make this the last one we do, because I didn't write a 21. Get out of here, orange writing. Number 20, I can go about this two ways. Right, I could do product rule. I could say y prime equals f g prime plus f prime g, which means y prime is, I don't have to simplify, right? Simplified's an opinion, but if I did simplify, I would have 2x cubed plus x squared minus 2x squared plus minus x. And in this other one, I would have 2x cubed plus x squared minus x, and then when I combine them, I would have 4x cubed minus x squared plus x squared cancels, minus 2x. But that's the long way. I probably instead would rewrite y. If I rewrite y by distributing it before I even do the derivative, it's a minus b times a plus b. It's difference of squares. It's going to be x squared squared minus x squared. Derivative of that is 4x to the third minus 2x. I got the same answer, but I don't have as much fun doing it. Maybe I want to do it the green way. I don't know. Up to you. Hopefully this helps. I'm not going to be able to post the answers like this because it's all over the place with the way the ink worked, but hopefully the video maybe helps.